I am recording. And again, what we're going to be doing today is a review for our next exam, which you're going to be taking online by Sunday, the 22nd at 11:59 p.m. Again, please give yourself enough time to get started. I noticed that a lot of folks wait until about 9 or 10 to begin the exam. That's kind of too late. Give yourself plenty of time. I'm going to answer Nancy's questions. I'm going to start by sharing my browser with you. Okay, and just give me a second. Here's our course. Okay, and every module is put together pretty much the same way in that there are learning activities, which essentially have our week online, live online sessions. Okay, so if you click on this, okay, it'll show you, here's what we did on Tuesday, session 1, Z-scores, normal probability. This was the meeting link, which was available before the meeting started. Here is the YouTube recording. Okay, unfortunately, I'm having trouble actually inserting something that's clickable here. So what you're going to have to do is copy and paste this link into another tab to open the video recording. And then these are the files that go along with the recording. So in every week module of our course, okay, you'll see one of these live online sessions pages, and it has the links to the recordings. Okay, did that answer your question, Nancy? Okay, good. All right, anybody have any other questions? It's super important to know how to find things in the course. So at the risk of repeating myself, I'm going to show you something else. So go back to week 13, give it a minute, it'll bounce back. Okay, so here is, yeah, it bounces around, sorry. Here's week 13, which is where we are right now. And again, you can see you've got videos, you've got a web page, and you've got the notes that I'm going to use today. So whenever you see Z-scores and normal probability notes, this PDF file is pretty much what I'm using, and you can use it as guided notes if you want to follow along. So you can, if you want to, you can print it off in advance. But that is the file that I upload along with the video, and it has my completed work in it. Okay, so if you ever miss a live online session, you've got the video and you've got the notes from the live online session. Also, whenever I can, I put these online tools in the first module where they were relevant. Okay, so today we're going to be using a normal probability calculator. Turns out we're not going to use this, but I'll show you how it works because it's really handy in statistics, which is where some of you are going next. And then a Z-score calculator. Lastly, we've got the assignments for the week. Okay, so you've got homework. There is a practice exam, okay, that you can go through yourself, and I strongly recommend you do this. I'm going to go through my version of the practice exam, which may or may not have similar numbers to yours, okay, today. So I'll show you how I solve every one of the problems. Do this first before you actually take the Unit 3 exam, okay? So here's the real exam. This is the practice exam. When you're done with the real exam, as you're working, show as much work as you can. Even if you type something in your calculator, you know, or you use the normal calculator that's online, okay, just tell me what you did, okay, and then you can upload it here into the work assignment. This is a non-credit assignment, but it's a quick way for you to either scan in all your work, upload the file, or take pictures of all your work, upload the JPEGs, okay? So again, that gives me the opportunity to give you partial credit. And more importantly, I don't know if you realize it, but on all of the exams, there's feedback. Okay, if you actually get into the exam in review mode, you'll be able to see my feedback on questions where you didn't get full points. That's useful because it's telling you where you're struggling. Okay, it's not, I know in an academic environment, everybody's focused on grades. I get that. But it's really more important to understand where you're having a problem so that you can fix that going forward. Okay, so take a look at once the due date for the exam is passed, you'll be able to get in there and access the exam and review mode and see feedback. Okay. Last but not least, if you go past the end of the course, past the final exam, which is here, you'll see the texts that we're using, the full text, and then this online tools and calculators section. Okay, this is organized by unit. So you can, again, if you're struggling like with an exam, you can just open this up in one of your tabs and you'll be able to get to all of the calculators that are relevant for descriptive statistics. Okay, I personally like everything in one place, but again, you've got it both ways. They're in each of the individual modules if you remember where they were, or you have them all here. Okay, so again, before we move on, let me ask if there are any questions about this week's exam 3. Any questions? Any general questions? Like I said, we're going to do a practice exam right now, but any general questions about housekeeping? Okay, not seeing any. So what I'm going to do is I'm going to start with the notes. Now, again, in this case, we did the Z-scores already, okay? And you might be wondering, hey, she didn't leave any notes for the exam review. And that is true, because what I had to do in order to get this practice exam was I had to like print it off and then make a PDF out of it. Okay, so what I would ask you to do while we're going through the practice is focus on the problem and ask questions about how to do it. Maybe if you've got some pencil and paper handy, take some notes that describe how to do a problem. For example, the first problem is all about mean, median, and mode. So write yourself some notes saying, mean, median, and mode, use this type of calculator, okay? Rather than copying the problem exactly, okay? I find that copying a problem exactly is kind of a limited use because your problem might be a little different. You want like a cheat sheet for yourself going through the exam. How do I do this kind of problem? How do I do that kind of problem? This exam is extremely calculator dependent. So what I'm going to do is as I work through the problems, I'm going to use the online calculators that I know everyone has access to. Okay, if you're in this meeting, you have access to the internet, and so you have access to these calculators. If anybody really, really wants to see how to do it on a TI-84, okay, please ask. Okay, ask in the chat or unmute yourself and ask, hey, can you do that on the TI? And I'll bring up my emulator and show you how to do it. Okay, but again, I'm going to focus on the online calculators that I know everybody has. In some cases, they're easier to use. Okay, so let me begin by mirroring my tablet. This takes a minute, so sorry, folks. All right, and let me share that with you. Okay, so again, right now, everybody should be seeing my screen. Okay, and it says Unit 3 Practice Exam, and these are the directions for it. It says try to get it done in 3 hours. It's not timed, but that's the amount of time you'll have on the actual exam. The practice exam doesn't count in your grade because everybody gets full credit for it. Okay, so if you try it and you maybe get like 10 points on it because you gave up in the middle, don't worry, you get full points. Okay. Again, it's a good way to study is to actually try it. Okay, so this question's asking you to find the mean, the median, and the mode of the following data set. Don't do it by hand. You can, okay? But again, what I'd request you learn how to do is use one of the descriptive statistics calculators. You can use one variable stats in your TI, or I'm going to minimize this and show you again, see if I can bring up the descriptive statistics calculator. This is the thing that's linked into our course, right? And it basically says, enter your data set. You want to make sure you click sample, okay? And then again, usually the way you enter a data set is to enter either your numbers on separate lines like this, or put commas between them. Okay, so I'm going to try them on separate lines because that's just easier for me. And I'm copying from the exam. So just enter the data in the window like this. Okay, so that's my data. Okay, like give it a check, make sure, you've got it all, that sort of thing. I mean, typos in data are notorious for causing you a problem. Don't worry about it. Again, I can give you partial credit if you make a typo. All right, so I'm going to hit calculate, and it says working. And then if I scroll down, it gives me all of the one variable statistics. Okay, so I'm going to get a mean here of 107.85, which I'll write down. A median, which is 105.5. Okay, and if you notice, my mean is slightly larger than my median. That would tell me, if I couldn't see the data, that there might be some higher scores in my data. Okay, there might be more high scores than low ones, because remember, your mean is pulled by outliers. Okay, these are close enough, but I would say there aren't too many outliers. Okay. And then here's my mode is 122. So they're all right there in the data. You don't need to run separate commands. If they asked you for the standard deviation, you have that right here. When you guys get into stats, you'll find other measures of position called quartiles. Those are down here. They're not part of our question on the exam, but these are really useful. Quartiles in your interquartile range are useful in determining what data points could be considered as outliers. Okay, so that's just something useful. I really like this calculator because everything's all in one place. And you see the way they put my data in rows with commas. You could have also entered it that way. Okay, so let me stop and ask any questions about the calculator. Questions about the online calculator? Okay. Nope. Okay, good. All right, going back to my exam, I put my values in here. Okay. Question 2, the next one. Okay, so every year, students at a high school are given a musical aptitude test that rates them from 0, no musical aptitude, wow, that's harsh, to 5, high musical aptitude. Okay, here are this year's results. Okay, so this requires that you do a frequency. You want a mean, a median, and a mode. Okay, the online calculator, I don't see a way to put in frequencies here. So the only way you'd be able to do it here, unless we had a way to put in frequencies, I'd have to clear it. Okay, and then I'd have to repeat the values as many times as they were. So I'd have to say there was a 0 and it occurred 5 times. Okay, and then I can put my 1s on the next line. There are 2 of those. Remember to end each line with a comma. Okay, then 2s, there were 5 of those. All right, and 3, we've got 6 of those. And 4s, there were 3 of those. And the 5s, there are 3 of those. Okay, the last one isn't going to have a comma. That's a sample, so I'm clicking sample and then calculate. Okay, and then scroll down here. For my mean, I'm getting 2.375. And my median is 2.5. And my mode, which you can see from looking at the table, is 3 because it occurs the most times. Okay. Now, if you were to do this on a TI-84, okay, the one variable statistics gives you the opportunity to have a data list and a frequency list. So on a TI-84, you could put your data in list 1, your frequencies in list 2, and then just make sure when you run one variable statistics that you've got both of those in the function. Okay, let me just show you that real quick. I'll bring up my TI-84, get this out of the way, share the TI-84. Okay, so you all should see it. Okay, so again, the idea is you've got stat edit, you've got 2 lists, so you could put your numbers here, your frequencies here, and then when you go to one variable statistics, which is stat calc, you see you've got a list for L1 for the data, and then make sure you put list 2 here for the frequencies. Okay, so that's how you do it on a TI. All right, anybody questions? Again, I'm not sure how many of you are using the TIs, so I'm trying to hit all bases here. Okay, all right, going back to my notes. Like I said, if anything stops making sense or you need me to repeat something or you have a question, please just unmute yourself and ask. It's a lot faster. Right? Now this question, again, is similar to the last one. Okay, again, I've got a frequency for each one of these. This is tedious because I have to enter my this number 13 times, but I'm going to do it the same way on the online calculator. Okay, just repeat it that many times. Okay, I'm sure there are one variable stats calculators that allow for a frequency list. I just wasn't able to find them in a hurry. Okay, and I wanted to make sure you had something. So I'm going to go back and do this the tedious way. Okay, so over here, I'm going to scroll up and clear my data. All right, and again, I've got a sample, and I'm going to enter the data here. So I've got 28 students that occurs 9 times. 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then I have 29 students that occurs 6 times. Okay, so again, these are the number of average students in a math class. Okay, so then I have 30 students that occurs 13 times. 1, 2, 3, 4, 5, 6. Oops. See what I mean about fat fingers? That is 5 of them. 6, 7, 8, 9, 10, 11, 12, 13. Okay, and then I have 31 that occurs 7 times.
I feel like a problem like this is almost easiest to do in Excel than typing
it is
it in.
very easy. Would you like to see it in Excel? Let's do it in Excel. That's a great idea. I didn't think of Excel. Okay, you guys all have access to Office 365. So let me go here.
I think that would lessen the opportunity for error too.
Absolutely. Thank you for bringing that up, Alicia. Okay, so Office 365. Now you sign in with your Maricopa MEID, right? So and this will bring you to the Maricopa sign-in. Okay, again, it's done like on an enterprise platform. So the first login, gets you to this where I can log in with my Maricopa stuff, my Maricopa credentials. So it's annoying. Yes, there are 2 logins. All right, and then you get a whole bunch of things, okay? So I already have a MAT218 spreadsheet. If not, you would open a new one. So I'm going to open this. Okay, so again, you notice there are multiple tools. You don't have to use a TI for everything, okay? You can certainly use an Excel spreadsheet where it makes sense. Okay, so I'm going to create a new page here, a new sheet. Okay, and I'm going to call it exam 3. So that way we can find what we did. Okay, this is up in the cloud, so it gets saved as you use it. So let me put in the values here. Here are my number of students. And then the frequency is going to be in the second column. So here's 28, then 29, oops, then 30, 31, and the last one was 32. And then here are the frequencies, which avoid you, again, typing multiple things into that other calculator and possibly messing it up. Okay, so basically, if you want to find the mean, okay, how are you going to do that? Well, you're going to wind up having to multiply these together. Okay, so I'll call this x times f. Okay. And then basically you have to figure out, again, part of the problem is using the basic statistics that are in here with a frequency. Okay. And if you're not comfortable doing that, then you're going to wind up with problems. Okay. So if I multiply these 2 together, like if I say equals this times that, okay, and then tab off the cell, that's these 2 together. And then I can drag these down. Okay, so then each one of them is multiplying this times the frequency. Then all you've got to do is add these up and divide by the total of your frequency. So you have to do a lot more work here, okay, to get your answers. Right, so I need the sum of my frequencies. There are 39 numbers here, 39 classes that I'm finding the averages of. And then here, I basically need to sum this. Oops, I screwed that one up. Sorry. And then divide it by, that's the sum. And then basically this would be, if I want the mean, you need to take this divided by that. Okay, so I would take this divided by that. Okay, so the mean here is 29.77. Personally, I think that's a lot of work. What do you think?
I was just thinking of just putting, like, copying 28, putting it 9 times, copying 29, putting it 6 times, like not doing it by the frequency.
Not doing it by the frequencies. Okay, so here's another alternative.
Because that way you can just take the average of the column and
okay, and then you can use just the built-in functions. I like that idea better. Okay,
because I think there's a mode function as well. I don't know about
there's an average function you can use to get the mean. There's a median function, a mode function. There's also a standard deviation. You know, you can use the built-ins. Okay, so here's a better idea. You can take 28, right? And then I have to copy it 9 times, right? So I'm going from cell 11, right? How many times? Down to 20 or down to 19? That's 3, that's 6, that's 9. Okay, so just double check. That's 9 of them. Okay, and then I have 29. And I want to copy that 6 times. Notice how I'm copying. I'm just dragging on the corner. There's 6 of them. And then 30 is 13. This was the one that was the real bear, 30. And then I want 13 of them. Okay, and again, you've got to check you've got the right number. And then 31 happens 7 times. And the last 2, I think 32 is 4 times. Okay, there's only one more, 32. And that's 4 times. Whoops. Okay, so now let's get the statistics. I want mean. These are labels. Median, mode, and range. Range I can do in my head. I don't know if there's a built-in for range. I'll see if I can find it. Okay, so in Excel, mean is called average. Okay, and then I just highlight my whole column with my data. And tab off the cell. Okay, and I got the same number. Here's median. Do the same thing. Okay, close and then tab off. We got 30. Mode. Okay, mode multiple, mode single. I don't know if we've got multiple modes or not. I can tell by just eyeballing the data, okay? And if you look at the table, 30 occurs the most often, okay? So I have a single mode here, okay? Multiple mode would actually give you an array of multiple modes. So if you don't know, looking at your data, choose multiple, okay? I know my mode here is going to be one mode. And I don't even need to calculate it because I know what it is. I know it's 30. Remember, modes are the most common. And then range, let's see if we have a range. I don't, okay? So basically, it's the lowest value minus the highest value. So I can do this. And then just tab off the cell. So I took the highest value minus the lowest value, and that's 4. Okay? So it's clunky, okay? You might decide you'll just take your chances with the built-in one variable statistics calculator, okay? And simply just be careful counting out how many times you do it. You can do it here in Excel, but you've still got to be careful when you replicate the data values. Again, the TI-84 gives you that frequency list, so it's not a problem on the TI. Okay? Is everybody okay with Excel? Anybody questions about how we did this? All right, now I'm going to type in my values. Usually also they'll ask you to round to 2 decimal places or to the nearest hundredth. Please pay attention to the rounding. Okay, if I'm rounding to the hundredth place, that's where the 6 is. 9 says add 1. So the mean would be 29.77. Okay, so we're good with that. Thank you for suggesting Excel. I like showing a whole bunch of different ways to do things. Okay, as you move into your careers, you're going to find out there isn't just one right way. Okay, there's usually multiple right ways and 1 or 2 ways that are easier. You want to find the easy ways. Okay, but that takes practice. Okay, so that's why we're kind of going through multiple ways. All right, let's move on to a normal distribution. Now, they've given you a normal distribution, and they're showing you some scores that this distribution is based on. So why don't you work with me here and see if you can answer some of the question. Okay, where's the mean of the distribution? Where's the mean? Where's the mean, and how do you know?
In the middle, and it's 52.
Yeah, it's 92. Do you see where the lump is? Okay, this is your mean. Okay, and again, if you think about what median tells you, it says if you took all the scores and you arrange them from the lowest to the highest, that's what I have here, the median is the one in the middle. Okay, so that means that the mean is 92, the median is 92, and where's the biggest bump? It's over 92, which means the most commonly occurring score is also 92. Okay, this is the characteristic of a symmetric normal distribution. The mean, the median, and the mode all line up in the middle. Okay, remember we said that not every normal distribution is symmetric. The ones you're going to be working with in MAT218 and probably even in your stats class will be symmetric. Okay, but there's some real data out there that looks pretty skewed where this lump is off to one side. Okay, you can also tell the standard deviation. Okay, can somebody explain how do I tell the standard deviation from here?
You can just pick any 2 points that are next to each other and subtract them.
Right.
So
basically,
you can go
yeah.
from 100 to 108 and say that it's 8.
Yeah, this would probably be the easiest one to use. You can see these are 8 apart. These are also 8 apart. The reason for that is that 100 is the score that's 1 standard deviation above the mean. 108 is 2 standard deviations above, and 116 is 3 standard deviations above. You can even tell going the other way. If you take 92 and subtract 8, you wind up with 84 as the score that's 1 below. 76 is, 2 below because we subtracted 8 twice. In other words, 76 is 16 points below the mean. And this is -3. And again, you can see all of those scores are 8 apart, so your standard deviation is 8. Okay, so make sure you can do that, okay, with a curve. All right. Any questions on the normal distribution? Okay, I find that on exams, a lot of students are not quite sure what these are down here. Yes, they're scores, okay? They might be weights or, something else. They didn't tell us what the context was, but they're also showing you the scores that are at the different standard deviations, okay? So using the empirical rule, for example, I would know that 68% of the scores approximately in this distribution are between 84 and 100, right? Because 68% is between 1 standard deviation below and 1 standard deviation above, okay? So if you get a graph like this, make sure that not only can you tell the mean and standard deviation, but you can also estimate the proportions of the distribution between certain scores. Okay. All right. Here's a simple one. It gives us a bunch of data, sample, and it asks us to calculate the sample standard deviation. I can do that with my online calculator. So I'm going to go to my online calculator. All right, I'm going to clear everything in here. Uh-oh. What did that say? Page that you're looking for. I'm trying to reload the page and I can't seem to get my calculator to behave. So I may need to close this page and start over. There we go. Cleared it. Okay, sometimes when you're working online like this, you get glitches. So I'm just entering in my data from the table. Okay, another advantage is of using online calculators and spreadsheets is sometimes if you're like working with something electronic, you can select like copy and paste the data, which avoids totally the errors that you get from typing. Okay, so usually what I do when I finish with something like this, I just count. I got 7. Yeah, there are 7 here, and then just calculate. Okay, and again, it takes a minute, but it should give me my sample standard deviation when it's finished. And I get 5.55 as my sample standard deviation. Okay, it's important, again, to click sample because the way they calculate standard deviation is different for a population. Okay, and again, this one has multiple modes. Personally, I would say it has no mode, okay, but they are calling it everything as a mode. Okay, so I would not agree with this. All right. Going back to here, let's look at kind of an applied problem, okay? Suppose you want to invest money safely and you're trying to decide between stock options in 2 companies. Now, why would you want to invest safely? Well, let's say you're a couple of years out from retirement and you want to make sure that that money is there for you when you need it. Okay, likewise, say you're saving for something that's important, like starting a business, again, and you want the money to be there when you need it. Okay, a lot of folks invest in the stock market when they're younger, figuring I'm going to be adventurous. In other words, I'm going to go for the high growth stocks. And the risk is not that important to me because I have time. I can recover from a setback. Okay, that's part of what you need to talk about with a financial advisor. Okay, deciding the risk tolerance. So I have 2 stock options. They both have the same rates of return, but one company has much larger standard deviations in its rate of return. If you're interested in a safe investment, which company do you choose? If you're interested in a safe rate of return, what company do you choose? Okay, and again, I'm going to ask you why, so be prepared to answer why you picked what you did. Anybody have any ideas?
The smaller one, because if you lose money, you're not going to lose as much, but you'll still have a chance to gain.
Okay, well, in both cases, you might still have a chance to make up a loss, but what does a smaller standard deviation tell you about rates of return?
You're just going to lose less if you lose.
What it tells you is the rates of return don't vary that much, okay? A company with a larger standard deviation in its rates, 1 year it might pay 10%. The next year it might pay 0.1%. The next year it might lose money, okay? Whereas if you've got a smaller standard deviation, maybe you're making 2.25, maybe you're making 1.8, then you're making 2.1, but they're all clustered around 2%, okay? So you're kind of avoiding the large swings in rate. Okay. You're going to see when you take your stats course, variation turns out to be something that's really important. Okay, we're just kind of dipping our toe here in the idea of variation. Okay. All right, let's look at another applied question. Okay, about 1% of the population has a particular genetic mutation. 400 people are randomly selected. Find the standard deviation for the number of people with a genetic mutation in such groups of 400. Okay, so here they're kind of telling you multiple samples of 400. Okay. The first thing you need to decide here is what kind of probability distribution is this? Okay, so what kind of probability distribution? Okay, well, they're telling you a probability that any one person in the population has this mutation, 1%. Okay, they're giving you the total number of people in your sample, and they want to know the standard deviation, okay, of the number of people with that mutation. Okay, this isn't normal, okay, because they're not giving you a mean and a standard deviation. Okay, they're asking you for that. Okay, could this be a binomial experiment? In other words, we're selecting people out of the population, which we're assuming has millions of people in it. Okay, so if we pull a sample out of it, we're not really changing the probability of picking somebody with or without the mutation if we're choosing randomly. Okay, so if we consider getting somebody with this mutation a success, okay, so we're going to say success is the mutation. Okay, we have N is 400. P is 0.01. That's 1% as a decimal. And then remember, we also need 1 minus P. Okay, well, that's 100 minus 1, or 0.99. Okay, now here's the part you want to remember. In the reading, okay, and in our notes, there were specific formulas for the mean of a binomial distribution. Okay, so the mean is the number in the sample times the probability of success, which makes sense. Okay, I'd expect 1% of my sample of 400 or 4 people to have this mutation. Okay, they didn't ask me for that. They asked me for standard deviation. And again, I'm approximating the population standard deviation. That's the square root of N times P times 1 minus P. That's what you want to use here. Okay, so I'm going to plug in my values. 400 times 0.01 times 0.99. Okay, so this is what I'm doing. And again, I can do this on my Web 2.0 calculator. I'm going to bring that up so you can see how to do it. These are just shortcuts. There's one of these for just about every distribution you can think of, a shortcut for its mean or its expected value and its standard deviation. Okay, so we did introduce these for binomial. You want to make a note of those. So I'm going to go to my Web 2.0 calculator. And hopefully I can do this the way I want to do it. So square root of 400 times 0.01 times 0.99, and then close the parentheses. Okay, make sure it looks right. And you can see it's 1.989. If I'm rounding to 2 decimal places, this is 1.99. Okay. So I would say 1.99. All right, everybody all right with that one? Again, remember these are things, they're in the notes, they're in the reading. You just want to make sure you see them. Let's highlight them. Okay, everybody good with that? So the trick here was realizing I had a binomial distribution. Question 8, I want to work through this in detail, okay, because again, it's kind of hidden in the materials. I want to make sure everybody understands it. They want the standard deviation of a probability distribution. Now, they give you the values and the probabilities. You're probably used to saying, well, I can find the expected value of that, right? That's going to be 0 times 0.5 plus 1 times 0.3 plus 2 times 0.05 plus 3 times 0.6. Expected value, right? You multiply each outcome by its probability. Well, expected value can also be your mean, okay? And again, I'm not going to use mu, I'm going to use x bar because it's a sample, okay? Your expected value. You can evaluate this on a calculator. I did that and I got 2.2 as my sample mean, okay? Now to find the sample standard deviation, I'm going to start with variance. Okay, when you've got something with probabilities, remember what that is. Usually you take each value and you subtract the mean and then you square it, right? So it's squared deviations from the mean. So my first value is 0. I would subtract the 2.2 and then square it, right? So here's x minus x bar squared, okay? But they gave you probabilities. So you need to multiply by the probability as well. Okay, so the basic formula here, I'm going to erase and show you the formula, okay, is to take the data value minus the sample mean squared, multiply that by the probability of that value, okay, then we're going to add them all up and take the square root. Well, that's not for variance, okay, that's for, okay, that's for variance, okay, so that's what we're going to wind up doing. All right, so I'll start this over here. So 0 minus 2.2 squared times 0.05 plus 1 minus 2.2 squared times 0.3 plus 2 minus 2.2 squared times 0.05. And the last one is 3 minus 2.2 squared times 0.6. Okay, so basically these are the difference between each of these values here and my sample mean of 2.2, then squared, okay, and then multiplied by the probability. Again, this is something you can do on a calculator, okay? And when I did that, I got 1.06. Okay, that's my sample variance, right? It's sigma squared. And remember, standard deviation is the square root of variance. So that's going to be the square root of 1.06. Okay, again, you can do that with a calculator. Into 2 decimal places, I get 1.0. Okay, so the standard deviation, 1.0. Right, that's the way you find a standard deviation of a probability distribution. Okay, it has the same artifacts as any standard deviation, where you're taking each data value minus the mean squaring. Okay, so this is called squared deviations. Only difference is you're multiplying by probabilities. Okay, this gives you variance. Take the square root to get standard deviations. Okay, let me ask. Okay, questions on number 8. Anybody have questions on 8? Okay, it's a pretty straightforward process once you've got, the handle of how to do it. Okay. So again, you already know how to find the mean, right? That's the same as expected value. Once you get that, square your deviations from the mean, multiply by the probability, then square root. Okay, awesome. Don't hesitate to ask. Question 9. is asking, is this a probability distribution? So I'm going to give you question 9 and ask you, is number 9 a distribution? And then you have to justify your answer. So you're looking at the table. You have to remember what the criteria are for being a probability distribution. Anybody have any thoughts about this?
Yes.
Okay, Alicia thinks it is. Anybody else have any ideas? Okay, how about the rest of you? I've got 11 of you on. How about the rest of you?
I also agree with yes.
You agree with yes? Okay. Are there any no's out there? Okay. Why do you think it's a probability distribution? What are the 2 criteria?
So the probabilities of all of the values add up to 1.
Right. All the P of X's add up to 1. And the other criterion is all the P of X's are between 0 and 1. Okay? So let me just write that in notation. Okay, so they have to be valid probabilities. Okay, no negative numbers, no numbers greater than 1. Okay, so once you've got that, okay, and you realize these numbers add up to 1, yes, you know it's a probability distribution. If either of those criterion are failed, then it's not. Okay, so if you can tell, hey, I've got a negative probability, and you don't even check the sum, it's not a probability distribution. Okay. The next question is about a uniform probability distribution. Okay, so uniformly distributed, this is a continuous distribution. Okay, and we had a couple of examples of this in the homework. The time it takes me to wash dishes is uniformly distributed between 8 and 17 minutes. Okay, and they're asking you about a probability that the time it takes you to wash dishes tonight is between 2 different values. What you have to remember is how to build a probability density function for a uniform distribution. Okay, basically, the first value they give you is A, the second one is B, and the density function is 1 over B minus A. Okay, and essentially, we'll draw pictures so you can get a handle on what this means. But let's get the density function first. Okay, so my density function is f of x equals 1/9. Right? So if I actually want to draw a picture of this, okay, you can think of this as being my time axis. Okay, this is my probability axis, and I've got a 1/9 up here. All right, and my distribution goes from 8 to 17. Okay, and my distribution is 1/9 between those 2 values and 0 everywhere else. So it looks like this. Okay, there's my probability distribution. Now you're being asked for a particular chunk of this, namely from 10 to 12. Okay, so you want to know what's this area. Okay, because again, area underneath the distribution, underneath the density function, tells you the probability that any given observation will be in that part of the curve, right? So you want to try to find the probability that your dishwashing time is between 10 and 12 minutes. Okay, so the way you do that, I'm trying to find the area of the blue part. Okay, well, it has a width of 12 minus 10, right? That's how wide it is down here. And it has a height of 1/9. Okay, so again, that's the area of this blue rectangle, which corresponds to my uniform probability of being between 10 and 12 minutes. Okay, so then all I have to do is, this is the 2, this is 1/9. My probability is 2/9. Again, if they want it as a decimal, you round it to whatever they want. 0.22. Okay, you should be okay with a fraction. Although they're saying, I'm sorry, they're saying give your answer accurate to 2 decimal places. So change your fraction into a decimal. Okay. Everybody understand uniform distributions? They're super easy once you get the hang of them because everything's a geometric shape. Okay. It's real easy to find areas. Okay. Questions about number 10? Okay. All right, let's look at number 11. Okay, number 11. Suppose that you're offered the following deal. You roll a 6-sided die. If you roll a 6, you win $13. If you roll a 4 or a 5, you win $2. Otherwise, you pay $5. Now notice, I'm not paying to play the game. I only pay if I lose. Okay, so otherwise, that means if I roll anything but a 4, 5, or 6, so if I roll a 1, 2, or 3, okay, I have to pay $5. Everybody good with that? All right, so I want to build a probability distribution, so I need to list my outcomes, okay? So X is going to be the profit from smallest to largest, okay? And then the probability of that happening. Okay, so the least money I can win is actually to be in the hole $5. Okay, I could also win $2, or I could win $13. Those are my outcomes. Okay, then all you got to do is figure out the probabilities that go with. Okay, take a look. If I roll a 1, 2, or 3, I'm out the $5. What's the probability of rolling a 1, 2, or 3? Well, there's 6 sides on the die. Those are 3 of the possible outcomes. So this probability is 1/2. Okay. The rolls that give me a $2 win, there's only 2 of them. So 2 out of 6, or 1/3. And there's only one real winner, right? The 6. So the probability there is 1 out of 6. Again, you want to make sure you've got a probability distribution. You know you do because you accounted for all 6 sides of the die, okay? But if you wanted to, this is 3/6, this is 2/6, that's 5/6, plus 1 more 6, there's 6/6, it's 1, okay? And all these probabilities are between 0 and 1. Now they're asking you for expected profit. That's another way of asking you for expected value. So again, I'm going to take each one of my values and multiply it by its probability. Okay, and again, you can do this on any calculator. Okay, and if you do that, you'll get an expected value of 0.33. Okay. Now, this is your expected profit, 33 cents. Notice it's positive. Before I move on, okay, take a look at this PDF table. It says round to 4 decimal places. Everybody see that round? Okay, round to 4 decimal places. That means it wants these probabilities not as fractions, but as decimals, okay? It's a ridiculous requirement, but it's because we're using software, okay? The software won't convert the 1/2 to 0.5, okay? So enter them as decimals, okay? Pay attention to, the rounding directions if they're there. And again, this is another reason to show me work. So if you had put in fractions and it marked the whole thing wrong, I'd give you full credit. Okay, so show me your work. All right, so expected value is positive. Now let's interpret the expected value. Is that how much I'm going to win if I play a game? Is that the likely amount I'm going to win? Or is that the average amount I'm going to win? Which one of these do you think is the right answer? What does the expected value mean?
The one in the middle.
Yeah, it's essentially if you play this game lots of times, on average, you'll win about 33 cents per game you played. Now, on any given game, you're either going to lose $5, win $2, or win 13. But it will all average out to about 33 cents per game. Okay, so it's a long run average. Okay. Now, what do you think? Based on the expected value, should you play the game? Is it a good deal?
Not really.
Which one would you pick? Which one would you pick? Well, the expected value isn't negative, so we can skip the first one. It's a gambling game, and it's always a bad idea to gamble. Well, let me just tell you, there are some people who make their living gambling. Okay? What do you think?
The second one?
Yeah, the second one is the mathematically correct answer. Okay? Now, if you have moral reservations about gambling, then you would pick this one. Okay? Remember, you're picking the mathematically correct answer. Okay? Mathematical answer. Not moral answer. Okay, because your expected value is positive, in the long run, you're going to come home with more money than you left with. Okay, because you're winning on average 33 cents per game. You might play for a long time, though. Okay. Okay, let's take a look at the rest. The rest of them are things we can do with a calculator, except for the ones that ask you for an opinion. Okay. A manufacturer knows their items have a normally distributed length with a mean of 16.6 and a standard deviation of 2.9. Okay, so we have mu equals 16.6, sigma equals 2.9. These are population parameters. Okay, and the key word here is normally distributed. Okay, I want to know the probability that if I pick an item at random, it's less than 9.3 inches. I'm going to use the online normal calculator that I've linked to in the course. Okay, so I'm going to minimize what we're in right now. Okay, and here is the normal calculator. Where is it? Normal distribution. This is from Online Statbook, and again, it's linked into the course. So I'm going to plug in the mean, which was 16.6, the standard deviation, which is 2.9. And they said, I want to know the probability that any given item is less than 9.3. So I'm going to click below and put in 9.3, click recalculate, and I get a probability to 4 decimal places, which is exactly what they want. Okay, so there's an extremely low chance, okay, with a mean that high, okay, that I'm going to be less than 9.3. And again, what I like about this calculator is it's showing you the entire normal curve, and it's showing you the part of the curve that you're asking for. Okay, so I'm going to leave this up because we're going to keep coming back to it. But everybody all right using the online calculator? Okay, I strongly urge you to use this as opposed to normal CDF, because normal CDF requires you to play with the value. For example, if you want the right tail in normal CDF, you've got to do subtraction. Okay, so this one is a lot more straightforward. It'll give you exactly what you're asking for. Okay, all righty. A manufacturer knows their items have a normally distributed lifespan with a mean of 8.3. okay, and a standard deviation of 0.5. And then they want to know if you get one item randomly, what's the probability it will last longer than 9 years, okay? So again, going back here, I'm going to plug in my 8.3 and my standard deviation of 0.5. And this time I want it to last longer than, so above 9. And recalculate. Okay, so here I get a little bit more than 8% chance. Again, I'm out in the tail, but I'm not that far out in the tail. Again, copy your values to 4 decimal places. Okay? Again, if you've got comments or questions or concerns about what I'm doing, please unmute yourself and ask. Okay, I want to get through these as quickly as I can. Again, particular fruits weights are normally distributed. We got a mean of 581 grams, a standard deviation of 11 grams. And this time we want to know if a fruit will weigh between 594 and 617. Okay, this is a bear to do on a TI-84. Okay, so I'm going to use the online calculator. I'm going to put in the mean of 581. Standard deviation of 11 grams. And again, I'm interested in between two values. So notice how nicely it put these on my standard deviations. Here's my mean, and here are my standard deviations. That's really helpful for me to see that. So I want 594 as my low bound and 617 as my upper bound. Calculate. So 11.1181. So about 11.8%. So 1181. Please put all these in as decimals. Don't write them in as percentages. Okay, so I'm showing you how I'm writing them in. Okay. Now, this is interesting. Okay, for a standard normal distribution, they're asking you what value, okay, has about 60% of the scores less than it. Okay, so this is an inverse normal. Okay, think about what they're doing here. They're giving you an area and they want to find a score. In all of these, they gave you scores and they want areas. Okay, so I'm going to use my inverse normal calculator for this one. So let me see if I can find it up here. Okay, online stat book. I think it is here in inverse normal. Let's see if we can get back here. Yep, online stat book. Okay, this is the one that's linked into the course. Okay, now here they want the mean and standard deviation. Okay, and basically they said it was a standard normal distribution. That means the mean is 0 and the standard deviation is 1. Okay, everybody remember that? Okay, that's what a standard normal is. And again, they want us to tell them what I want to know for Z less than some number C, okay, that it has 0.6096 of the area below it, okay? So I want to know below, okay, below that value, okay? And again, I didn't even have to hit recalculate, okay? So put the area they give you here, okay, the mean and standard deviation here, and then again, look at the inequality symbol. Here they said below this value, below this Z value. So again, 60% or almost 61% of the distribution is below 0.278. So that's what this is. The score is 0.278 here. Okay, so again, if I go back here, okay, that's the score that much of the area is below. Okay, so this is an area. Okay. Any question on 15? So let me ask that. Questions on 15? Again, 15 is backwards.
So we just know that it's an inverse normal because of the C value?
Yes, okay, with all of the previous ones, okay, they're giving you scores and asking you for probabilities. Here they're giving you a probability for an area, right? Area and probability mean the same thing. Okay, and they're asking you for a score. Okay, so that's how you know it's inverse. Okay, so if they give you, again, they're saying the probability that Z is less than some score C is this number. So the P is telling you this is a probability.
Okay.
Okay. All right. In a normal distribution, a data value is located 0.8 standard deviations below the mean. Okay. Again, it's a standard normal. Okay. It's below the mean. So the Z-score would be negative 0.8. Okay. So it's 0.8 standard deviations below the mean. That gives it the negative score. In a normal distribution, a value that's 1.7 values, standard deviations above the mean, has a Z-score of 1.7. Okay, so again, Z-scores that are below the mean are negative, Z-scores above the mean are positive. Okay, and in a normal distribution, the mean has a Z-score of 0. Okay, because everything is measured relative to the mean. Okay, so the mean is got a Z value of 0. Okay, everybody okay with 16? So the one is negative. Alrighty. Well, not too many left. We're almost done. Okay, so here are some empirical rule questions. Right, want to make sure everybody's good with these. Okay, a set of exam scores is normally distributed with a mean of 74 and a standard deviation of 6. So I'm using my standard deviation, right? Plus 6, plus 6, plus 6. Okay. Then I'm going to do the same thing on the other end. I'm going to take 6 away from 74, then take it away again, and take it away again. Okay. So I put my scores here that correspond to the mean and my standard deviations. Anybody have questions on the way I drew the normal curve? You've got to be able to do that to answer the question. Okay, so the mean goes in the middle. You keep adding standard deviations, plus 1, plus 2, plus 3. You subtract them, minus 1, minus 2, minus 3. Okay, now the empirical rule basically tells you that 68% of the scores are between minus 1 and plus 1. Okay, and then it tells you 95% of the scores are between minus 2 and plus 2. And last but not least, I have to draw it down here because I ran out of space, 99.7% are between minus 3 and plus 3. Okay, that's the empirical rule. So once you draw that on your diagram, you just copy the scores. 68% are between 68 and 80. That's one standard deviation below, one above. 95% are between 62 and 86. 2 below, 2 above. And the last one, 3 below and 3 above, has 99.7, 56, and 90. Anybody questions about the empirical rule? Okay, make sure you can reproduce this picture. Okay, and that you can put the right scores down here. Likely in your example, the scores will be different. Okay. Z-scores. Okay, so then this is just interpretation. We don't have to compute anything. If a data is a weight data, the Z-score of someone overweight, that means they'd be above the mean. So their Z-score would be positive. Okay, if the data set is IQ scores, an individual with a negative IQ score would have an IQ below the mean, so a low IQ. Okay, again, we're not discussing whether these are valid measurements. There's been a lot of controversy in the last 20 years saying IQ scores are a waste of time and money. Okay, I totally agree with that. This is just asking a math question. Okay, anything that's above the mean has a positive Z-score, below the mean has a negative Z-score. If you spend if you spend time watching TV, an individual with a Z-score of 0, remember 0 is the same as the mean, okay, mean amount. Okay, so just asking you to interpret the Z-scores. Okay, last but not least, if data is annual salary in the U.S. and the population's all legally employed people in the U.S., the Z-scores of people who make minimum wage, okay, would be what? What do you think the answer to part B is? This requires you to interpret the English a little. Anybody have an idea for part B? Yeah, the key word here is minimum wage. Okay, that means that's the lowest amount you can legally pay somebody. Okay, so that would be definitely below the mean. Okay, so negative. Okay. All right. Last two questions involve Z-score calculations. There is a Z-score calculator that I put into the course. We can use that. Okay, Z-scores are real easy to calculate by hand. The formula is take your data value, subtract the simple mean, and then divide by the sample deviation. Okay, and you can even use population mean if they give one. Okay, so these are normal. They're giving me a population mean and standard deviation. But again, I can use the calculator. So here I have mu equals 69.2 and a standard deviation of 2.64. Okay, that's for men. And for women, I have a mean that's a little smaller, but a bigger standard deviation. No, a smaller standard deviation. 2.55. Okay, so roughly the same amount of variance, just different mean. Okay, now here's the trick with this question. Okay, is the means and standard deviations are given in terms of inches. You need to be able to convert 6 feet 3 inches to inches. All right, 6 feet is 72 inches plus 3, so he's 75 inches tall. A woman is 5 feet 11, that's 60 inches plus 11. She's 71 inches tall. You need to be able to convert. Okay, so again, figure out how you're going to do that. There are online converters that'll tell you, 6 feet is 72 inches. Okay. So again, here I would just want to find this guy's Z-score. He's 75, and I have to use the men's distribution. Okay, so let me go out to the Z-score calculator. Quick Z-score. That's here. This is also linked into our course. Okay, raw score is his height. He's 75 inches tall. And then I want the mean of his population. That was the men. Okay, so that's 69.2. And the standard deviation for the men was 2.64. And then just hit the calculator. Okay, so he has a z-score of 2.196, which would be, if I wanted it to 2 decimal places, look what happens. The 6 adds 1 to the 9, which flips everything to 2.20. Okay, but this does the calculating. I'll do the woman while I'm here. She was 71 inches tall. Her distribution had a mean of 64.2. And her standard deviation was 2.55 for the women. Calculate that z-score. And that z-score would be 2.67 for the nearest hundredth. Okay, anybody questions about the z-score calculator? Everybody okay with the z-score calculator? Okay. Now let's look at the interpretation problem. Okay, so they want to know, select an answer, it's the man or the woman. Okay, who's relatively taller? Okay, now you're looking at this, you're saying, the woman's shorter by like 4 inches. What do you mean relatively taller? It means relative to their distribution. To all men or all women, who's taller? Okay. Who is taller? Okay, what do you think? Remember what these are telling you. These z-scores are telling you their position on the curve. How many standard deviations they are above the mean. They're both above the mean, right? Because they've got positive z-scores. But who's further from the mean?
She is.
Right. Okay, so she's further above her mean because her z-score is bigger. Okay, so the woman is relatively taller. That means compared to all women, she's taller by a lot than her distribution. The man's taller, but not as much. Okay, does everybody understand what the z-scores are showing you? They're showing you position relative to your distribution. Okay, she's further out in the tail of her distribution at 5'11". Okay, and ta-da, last question. Okay, we have a variable that's normally distributed, okay, with a mean of 22 and a standard deviation of 3, and you're just trying to find the z-scores for these particular x values. So I'm going to go back to my z-score calculator, and I'm going to put in a mean of 22, a standard deviation of 3, and then these are going to be the various raw score values. Okay, so raw scores. Okay, and I'm just going to do that. I'll do them all at once, so we get them all at once. Okay, so my population mean is 22. Oops. And my standard deviation is 3. That's going to stay the same for all of them. And then I'm just going to put in the raw scores. So 18. Okay, calculate that. That should be below the mean, right? So I would expect a negative z-score. And again, round these to 2 decimal places. I skipped the first one, that was 27. Okay, what's good is you can just keep using the calculator and just plugging in what you need. Okay, 27 is definitely above the mean. Okay, this would round to 1.67. My next raw score is All right, they want me to figure out what value has a z-score. Okay, so I have to do these a little differently. So let me come back over here. Okay, so I put in the raw scores for the z calculator. Now they're saying what value of x has a z-score of 2.67? Okay, you could use an inverse normal calculator, but it's a lot easier to do it this way. Okay, and again, 2.67 equals x is what you're looking for. Your mean is 22, and your standard deviation is 3. So all you have to do is a little bit of algebra. Multiply both sides by 3, right? And then just add 22. Okay, so I would do this calculation. Okay, so again, I'm just using my z-score formula, multiplying both sides by 3. Okay, and then what I would have, once I did that, I'd have this. Okay, so you would just add 22 to both sides. Okay, and that would give you 3 times 2.67 plus 22 equals x. And if you run that on a calculator, okay, you'll get 30.01. Okay, same idea with the rest of them. You do them the same way. Z-score is negative 0.03. Okay, you have your x value, which you're looking for, minus the mean over the standard deviation. Multiply by 0.3. Multiply the negative 0.3 by 3. That gives you this. Okay, and then you can just add the 22 to both sides. So you have 3 times negative 0.3 plus 22 equals x. Okay, in this case, you got to remember you've got a negative 0.9 here. Okay, so this is going to be 21.1 is x. Okay, and which value of x has a z-score of 0? That's your, and have to calculate. Okay, how are we with all of this? Anybody questions on anything on the review? Okay, I'm going to come back to our meeting. And I'll ask one more time, questions on anything? Questions on anything?